Have you ever wondered what auroras are? They are indeed a captivating spectacle of nature, a vibrant light show that paints the polar skies with a spectrum of colors. These displays are more commonly known as the northern and southern lights. In the north, they're called aurora borealis, and in the south, they go by the name aurora australis. The term aurora is derived from the name of the Roman goddess of the dawn, a fitting tribute to these dawn-like displays. These mesmerizing lights are not just an ordinary spectacle, but a phenomenon deeply rooted in science, specifically in the relationship between the Earth's magnetic field and solar wind. They are typically seen in polar regions due to the Earth's magnetic fields. So these lights are not just for our viewing pleasure, they are a testament to the sublime interactions between our planet and the sun. So next time you see those beautiful lights dancing in the sky, you'll know they're not just a pretty sight, but a fascinating scientific phenomenon. Imagine a solar storm. It sounds like something from a science fiction movie, doesn't it? But it's actually one of the key factors behind auroras. To understand auroras, we must first look to the sun, the life-giving star at the center of our solar system. The sun is a hotbed of activity, constantly emitting streams of charged particles into space. These particles, also known as plasma, form what we call solar wind. Now, solar wind is not like the wind you feel on a breezy day here on Earth. It's a stream of charged particles that races through space at speeds of up to 1,000,000 miles an hour. Yes, you heard that right. 1,000,000 miles an hour. When these solar winds reach Earth, they interact with our planet's magnetic field, causing disturbances known as geomagnetic storms. This is where the magic of auroras begins. As the solar wind interacts with the Earth's magnetic field, it funnels some of these charged particles towards the poles. Here they collide with atoms and molecules in our atmosphere. Each collision results in a tiny burst of light. Multiply these tiny bursts by billions of particles, and you get the spectacle of light we call an aurora. Now you might be wondering, why do these light shows mostly occur near the poles? That's because of the shape of our planet's magnetic field. It's similar to a bar magnet, with the field lines entering and exiting near the poles. This shape guides the charged particles towards the polar regions, causing the auroras to light up the sky in these areas. So while it might seem like a fantastical light show designed for our viewing pleasure, there's actually a lot of science at work here. From the sun's fiery emissions to the Earth's protective magnetic field, to the tiny atoms in our atmosphere, each plays a crucial role in creating the mesmerizing beauty of auroras. In essence, auroras are the Earth's way of showing us the invisible forces at play in our universe. Now, you might be wondering, why are auroras usually green? Or why do they sometimes show other colors? Well, to answer that, we need to delve into a bit of science. It all comes down to the interaction between the Earth's atmosphere and the particles from the sun. The dancing colors of the auroras are essentially a cosmic light show, with the Earth's atmospheric gases playing the roles of the stage and the performers. The most common color displayed in an aurora, a sort of ghostly green, is due to the presence of oxygen in the Earth's atmosphere. When the solar particles collide with oxygen molecules, the energy of this collision is released as light. This light is typically green because of the specific way oxygen molecules emit light when they're excited. But the story doesn't end there. Depending on the type of gas the solar particles collide with, and the altitude at which this collision happens, different colors can be produced. For instance, at extremely high altitudes, where the atmosphere is thinner and composed mostly of oxygen, the auroras can sometimes appear red instead of green. This happens because oxygen emits red light when it's excited at low densities. On the other hand, when solar particles collide with nitrogen molecules, which are more common at lower altitudes, they can produce a blue or purplish red light. Nitrogen emits blue light when it's excited and then quickly returns to its ground state, and purplish red when the relaxation process is slower. So the color of an aurora is a direct reflection of the type of gas and the altitude at which the solar particles are interacting. The colors are not just beautiful to look at, but they provide valuable information about the composition and density of the Earth's atmosphere at different altitudes. So the next time you see an aurora, remember, its colors are telling a story about what's happening miles above the Earth's surface. So where and when can you witness this magnificent spectacle of nature? Auroras, those ethereal light shows in the sky, are best seen in the polar regions, where they're often referred to as the northern and southern lights. In the northern hemisphere, Places such as Alaska, Canada, Iceland, Greenland, and northern Scandinavia are top spots. On the other side of the globe, Antarctica and the southern tip of New Zealand offer the best views of the southern lights. But the location is just one piece of the aurora watching puzzle. The time of year also plays a crucial role. Although auroras happen throughout the year, they're most visible during the winter months. This is because these regions experience long, dark nights, creating the perfect backdrop for the vibrant colors of the auroras. Plus, winter skies are often clearer, making them ideal for stargazing and aurora hunting. Now, if you're thinking, "But I don't live anywhere near the poles," don't fret. During particularly strong solar storms, these radiant displays can sometimes be seen at lower latitudes. For instance, there have been reports of auroras visible as far south as Texas and the Mediterranean. However, these occurrences are rare and unpredictable, so it's always a treat when they do happen. Of course, even if you're in the right place at the right time, there's no guarantee that you'll see an aurora. These natural phenomena are at the mercy of solar activity, which is constantly changing. But don't let that deter you. The thrill of the chase is part of the allure, and when you do catch an aurora, it's an experience you won't soon forget. But what about the time of day? Well, the best time to see an aurora is typically around local midnight. But remember, patience is key. Auroras can appear suddenly, and their intensity can change quickly. So pack your bags, bundle up, and get ready for an adventure. And don't forget your camera. You'll want to capture these breathtaking scenes to relive the moment and share with others. Remember, witnessing an aurora is a matter of being in the right place at the right time. So let's recap what we've learned about auroras. These celestial spectacles, also known as the northern and southern lights, are more than just a feast for the eyes. They are the result of a fascinating interplay of solar and terrestrial science. Auroras originate from the sun, the star at the heart of our solar system. When the sun emits a solar flare, it also releases a cloud of gas called a coronal mass ejection. These particles, primarily electrons and protons, travel towards Earth, carried by the solar wind. Upon reaching our planet, they interact with the Earth's magnetic field, which guides them towards the polar regions. Here they collide with oxygen and nitrogen molecules in our atmosphere, causing these molecules to emit light, creating the awe-inspiring displays we know as auroras. The vibrant hues of auroras are not just random. They are a direct result of the type of gas molecules the solar particles interact with, and the altitude at which this interaction occurs. Oxygen molecules, for example, produce green and red lights, while nitrogen molecules yield blue or purple hues. The color spectrum of an aurora is therefore a direct reflection of the atmospheric composition and altitude. While auroras occur around the clock, they are most visible during dark, clear nights. Geographically, they are most commonly seen in the high-latitude regions, near the Earth's magnetic poles. This includes the northern parts of Canada, Norway and Russia, and the southern parts of New Zealand and Australia. However, during periods of intense solar activity, they can occasionally be seen at lower latitudes. Armed with this knowledge, you're now ready to fully appreciate the next aurora you see. Thank you for watching, and don't forget to subscribe, like, and share our video and channel for more fascinating science content.